Hello, so today we are going to look into the past year question number 1. A1, define the coefficient of linear thermal expansion. What is coefficient of linear thermal expansion? It is a fractional increase in length of a solid per unit rise in temperature. Secondly, the question is, a pair of eyeglass frame is made of explosive plastic. At 20 degrees Celsius, the frame has circular lens holes of radius 2.2 cm. If the coefficient of linear expansion of an explosive is 3 times 10 power of negative 4 degrees Celsius power negative 1, to what temperature must the frame be heated so that a lens of radius 2.21 cm fits the frame? So we collect the information from the question. The initial temperature is 20 degrees Celsius, the initial radius is 2.2 cm, and the coefficient is 3 times 10 power of negative 4 degrees Celsius power negative 1, and the given final ratio is 2.21 cm. So what is the final temperature? So we use the formula R equals to initial R bracket 1 plus coefficient times the change of temperature. So we insert the information given. 2.21 equals to 2.20 bracket 1 plus 3 times 10 power of negative 4 times the change of temperature, which is the final temperature minus the initial one, 20, and we will get 15.15 equals to the change of temperature. So we get the final answer of the final temperature is 35.15 degrees Celsius. So for question B, an insulated spherical glass bulb of radius 2.5 cm, thickness 0.4 mm, whose outer surface temperature is 30 degrees Celsius, dissipates 55 watt of heat. Given the thermal conductivity of glass is 0.84 joule per second per meter per degree Celsius, calculate the temperature of the inner surface of the bulb. So we collect the information, which is radius equals to 2.5 cm. We need to convert to meter, so it's 0.025 meter, while the thickness we will get 4 times 10 power of negative 4 meter, and the outer surface temperature is 30 degrees Celsius, while the change of heat energy, which we use dq over dt as the symbol, is 55 watt. So the formula of the area of sphere is 4 pi r squared. So we insert the radius, then we will get the area of the sphere is 7.85 times 10 to the power of negative 3 meters squared. And we use the formula, the change of heat energy equals to negative Ka times the change of temperature over the thickness. So we will get the final answer equals to inner temperature equals to 33.33 degrees Celsius. So for So the dt over x graph, the gradient will be a straight line. We look at our graph, the initial temperature will be 33.3 and the final one will be 30 degrees Celsius, while the distance, which is also the thickness, is 0.4 mm. So here's the final graph.
2A1 Roman, define heat. Heat is defined as the energy that is transferred from one body to another because of a difference in temperature. 2A2 Roman, define temperature. Temperature is defined as a fundamental quantity that measures the degree of hotness of a body. For 2B, The length of a metal bar is 300 cm at negative 30 degrees Celsius. Given the coefficient of linear expansion of the metal bar is 11 times 10 power of negative 6 per degree Celsius. Calculate the length of the bar at 80 degrees Celsius. So, first thing we jot down all the information. So, L0 equals to 300 cm and T0 equals to negative 30 degrees Celsius. T equals to 80 degrees Celsius and the coefficient or alpha equals to 11 times 10 power of negative 6 per degree Celsius. And for this question, we use this formula. And from the formula above, we have all the information except for the delta T. So we need to find the delta T. So delta T equals to T time minus T naught. And so we substitute the information into the formula and we got 110 degrees Celsius. And after we got delta T, we just substitute the information into the formula, and the length of the final answer is 300.363 centimeter.
Is negative 0.5 Celsius. The time given is 24 hours, so we need to change it into seconds. The area given is 2.4 meters square. And the thickness x given is 1 centimeter. So we need to change the centimeter into meter. From all the information given, we can use the rate of change formula. So we just fill in the formula. Thermal conductivity coefficient is always negative. It's up. Thank you.
Okay, so question 4, define the coefficient of area thermal expansion. So we give the definition. The coefficient of area thermal expansion, beta, is defined as the fractional increase in area of a solid per unit increase in temperature. Okay, so question B, Roman 1. The question asks the lowest temperature if both metals are heated until the clearance is 0. Clearance is 0 means area of aluminium is equal to the area of brass. So I use the formula A equals to the M naught multiple 1 plus beta delta T, which is A naught is pi r square or pi d, and then beta is 2 alpha. And I use the information given and then I insert in the formula, which is it will give 5 square multiplied by 1 plus 2 multiple 2.4 exponent negative 5 multiple T minus 20 is equal to the 5.002 square multiple 1 plus 2 multiple 1.9 exponent negative 5 multiple T minus 20. And then I simplify the number in the bracket and it will give 1 plus 4.8 exponent negative 5t minus 9.6 exponent negative 4 equal to the 25.020 multiple 1 plus 3.8 exponent negative 5 t minus 7.8 exponent negative 4. And then the number in front of the bracket, we multiply with the number in the bracket and it will give 25 plus 1.2 exponent negative 3t minus 0.024 equal to the 25.020 plus 9.508 exponent negative 40 minus 0.019. And then the lowest temperature, we get 100.3 degrees Celsius. Okay, next is question B, Roman 2. Would such a tightly fit be possible if the plate is aluminium and the rod is brass and both metals are heated? Explain your answer. So my answer is a tightly fit would not be possible because alpha aluminium more than alpha of brass. Therefore, when temperature increase, hole in the brass plate and aluminium rod expand at different rates.
Soalan 5 PSPM. A. Define the coefficient of volume thermal expansion. The coefficient of volume thermal expansion of a solid is the fractional increase in volume of solid per Kelvin increase in temperature. A composite rod is made up by joining a copper rod of diameter 4 cm with an iron rod of similar diameter. The rod is insulated and its ends are kept at two different temperatures as shown in figure 12.2. The coefficient of thermal conductivity of copper and iron are 385 Wm-1 and K-1 and 80 Wm-1 K-1 respectively. Determine the temperature at the joint. Given that the temperature of copper is 160 degrees Celsius, the temperature of iron is 40 degrees Celsius, Xc is 8 cm which is 0.08 meter, Xi is equal to 5 cm which is 0.05 meter, and the thermal conductivity of copper is 385 and the thermal conductivity of iron is 80 Wm-1 and K-1. Let the temperature at the joint is equal to theta J. At the steady state, the rate of heat flow of copper is equal to the rate of heat flow of iron. The formula is as below. Negative Kc AC in bracket 180 minus theta J over 0.08 is equal to negative Ki AI bracket theta J minus 40 over 0.05. Since the AC equal to AI, it cancel out each other. Substitute the respective values in the formula. The final answer is, which is the temperature at the joint is 130.06 degrees Celsius. Thank you.
For question 6, a 200 cm cube glass cylinder is filled to the brim with mercury at 27 Celsius. Calculate the amount of overflow when the temperature of the system increased to 100 Celsius. The coefficient of linear expansion of the glass and mercury are 4 times 10 negative 6 Kelvin negative 1 and 6 times 10 negative 5 Kelvin negative 1 respectively. So we use the formula delta Vg equal to coefficient of volume expansion G Vu delta T, where the coefficient of volume G equal to 3 alpha. So we substitute the value and we get 0.1752 cm cube. Next, we use delta Vm equal to coefficient of volume expansion M Vu delta T. Then we substitute the value and we get 2.628 cm cube. After that, we calculate the V overflow equal to delta Vm minus delta Vg, and we substitute the value of delta Vm and delta Vg, and we got the V overflow is 2.5 cm cube.
PYQ Chapter 12, Question 7. A. Define heat. Heat is defined as the energy transfer due to a temperature difference and is caused by the movement of atoms and molecules in a body. B. Figure shows a rod with both ends in different temperatures. The right half of the rod is insulated while the left is not insulated. Sketch graph of temperature against distance of the rod. As we can see, the left side is not insulated with 27 degrees Celsius, while the right side is insulated with 100 degrees Celsius as its temperature. Hence, to sketch a graph, we start off with 27. Since it moves from a lower temperature to a higher temperature, we draw a curved line from 27, and then we proceed with a straight line till it reaches 100 degrees Celsius.
Next is passing question for question 8. The dimension of an aluminium wire at room temperature, which is 27 Celsius, is 150 meter long and cross-sectional area of 3 multiplied by 10 to the power of -6 meters squared. It is then melted to form a spherical ball. If the coefficient of linear thermal expansion of the aluminium is 22.2 multiplied by 10 to the power of -6 meter Kelvin -1, calculate the volume of the spherical ball at room temperature. Okay, pertama kali kita kena keluarkan maklumat yang diberi. Okay, kat sini maklumat yang dikasih adalah initial temperature. Kedua, dia bagi kat sini long 150 meter. Dia juga bagi area 3 darab 10 kuasa -6, dan juga dia bagi alpha 22.2 darab 10 kuasa -6. Okay. Jadi, soalan pertama, dia nak volume untuk spherical ball dekat room temperature. Jadi, kita guna formula V sama dengan area darab dengan panjang. 3 darab 10 kuasa -6 darab dengan 150, kita akan dapat 4.50 darab 10 kuasa -4 meter cube. Soalan kedua, dia minta change in the volume of the sphere if it is heated to 200 Celsius. Okay. So kita tahu final temperature is 200 Celsius. So change in temperature, kita kena buat 200 tolak dengan initial temperature which is 27 Celsius. So kita dapat 173 Celsius. Okay, jadi untuk mencari change in volume, kita kena cari dulu gamma. So formula gamma is gamma sama dengan 3 alpha. So alpha dia dah bagi, so kita selesaikan akan dapat 6.66 darab 10 kuasa -5 meter Kelvin -1. Okay, untuk cari change in volume, kita guna formula gamma darab dengan initial volume darab dengan change in temperature yang kita dah cari tadi. So 6.66 darab 10 kuasa -5 darab 4.50 darab 10 -4 darab dengan 173, kita akan dapat 5.18 darab 10 kuasa -6 meter cube. Okay, soalan last. Dia nak change in the volume of the sphere if it's cooled to -7 darjah Celsius. So, kita kat sini dia dah bagi info the final temperature, iaitu -7 darjah Celsius. Jadi kita kena cari the change of temperature. -7 tolak dengan 27. Jadi kita akan dapat dia punya change in temperature dia -3.4 darjah Celsius. Jadi kita guna formula yang sama untuk cari change in volume. Gamma darab dengan initial volume darab dengan change in temperature, gantikan dan kita akan dapat -1.02 darab 10 -6 meter.
So for passing question chapter 12 number 9, a gold rod is in contact with a silver rod. The gold end and silver end of the compound rod is at 90 degrees Celsius and 30 degrees Celsius respectively. The silver rod has thermal conductivity 427 watt per meter Kelvin, length 2.5 centimeter, and the cross-sectional area 7.85 exponent -5 meter square. If 341.3 joule heat flows through the gold rod in 10 seconds, calculate the temperature at the contact surface. So ni silinder dia. So gold belah sini, silver belah sini. Kita nak cari TC. So T1 dia 90 degrees Celsius and T2 30 degrees Celsius. And then length for silver rod is 2.5 cm. Kita boleh tukar jadi 0.025 meter. And then for silver rod, equation dia dq over dt equals to negative Ka T2 minus Tc over L. So where K is 427 watt per meter Kelvin and A is 7.85 exponent -5 meter square. So kita masukkan je nilai. So dq sama dengan 341.3 over 10 sama dengan negatif 427 darab dengan 7.85 exponent -5, and then darab dengan T2 kita 30 tolak dengan TC over 0.025 meter. So TC kita akan dapat 55.45 degree Celsius. So for B, the area of a metal plate changes from 120 meter square to 120.059 meter square when the temperature increases by 30 degrees Celsius. Calculate the coefficient of the linear expansion of the metal. So change in area of metal plate, equation dia delta A equals to beta A delta T. So beta sama dengan 2 alpha. So kita boleh tukar beta ni sama dengan 2 alpha. So A sama dengan 2 alpha A delta T. So the coefficient of linear expansion alpha sama dengan delta A over 2A delta T. So kita boleh masukkan information yang kita ada. So alpha sama dengan 120.059 minus 120 over 2 darab dengan 120 and then darab dengan 30. So kita kira alpha sama dengan 8.19 exponent -6.
Untuk soalan 10, a perfectly insulated aluminium rod has length 50 cm and cross-sectional area 3.0 cm squared. At a steady state, the temperature at 0 cm and 50 cm ends are 150 degrees Celsius and 50 degrees Celsius. The thermal conductivity of aluminium is 210. First, kita keluarkan info yang diberi dan tukar unit kepada unit SI. A. Sketch a label graph of temperature against distance. D. Saya lukis graf berdasarkan maklumat yang diberi. B. Calculate the temperature gradient along the road. Saya pakai formula ini. Lepas tu ganti value of temperature dan akhirnya dapat jawapan negatif 200 degree Celsius per meter. Calculate the rate of heat flow in the road. Saya guna formula ini, lepas tu gantikan nilai masing-masing. Akhirnya dapat jawapan 12.6 watt.